So a couple things to keep in mind is that, you know, open note quiz, so and it's only on 3.12, so make sure you have everything tomorrow. If you missed any days, you didn't finish an assignment, you all know where to go to find keys to everything, videos if you need to watch them, of course. And then it's not multiple choice, so I can give partial credit. So when you do these problems on your quiz tomorrow, make sure, even if you're like, I don't know what I'm doing. I mean, try something, because I can give you some points, even if you don't finish it. Maybe you start it, you just don't know how to finish it or something, okay? So just keep that in mind. And I'm not trying to trick you. I made the quiz up. It's not like a college board quiz or something like that where they get kind of crazy with their questions. This is something I made up, and so I really made sure that I picked problems that were super closely related to ones that are exactly in your notes or your homework. And there's a review problem here right at the beginning, and in the homework, there's 4 of the new type of problem, and I added 2 problems at the bottom that are also review. These review problems are here for a reason, okay? I made the quiz, went back over and thought, what can I do for them on Monday to help bring it all together? And that's those review problems, okay? So take those seriously too. Really, today's assignment covers all the days, really, okay? So in this very first example here, also, don't forget the mock exam is Friday. We've been talking about it. I'm going to have a sign-up sheet for it tomorrow. You can change your mind. It's not I'm going to yell at you if you change your mind, but I really would like to get a good idea about it. And like I said, I think last week, who knows, sometimes I repeat myself so much because I'd rather repeat myself than not say it again, because I say the same thing 5 times a day. That if you want to sign up, but you're still waiting for a work schedule, or you're waiting to find out if you have a ride, whatever it may be, go ahead and sign up tomorrow on the sheet, and then you can just maybe have a conversation with me, there's a chance I might not be able to, blah, 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 okay? But I hope that you guys can, but again, I understand if you can't, okay? All right, so let's do this problem. This is one of your sum and difference problems. There's 2 of these on the quiz. I even wrote above them, use your sum and difference formulas, okay? And what we are doing with a problem like this is finding 2 angles on the unit circle that add or subtract to get 17 pi over 12, okay? Any 2, and a bunch of us could have different ones and still be get the same answer, get the right answer, okay? So you have to find 2 angles on here that when you add them together or subtract them, makes 17 pi over 12. And if you remember, we start out using quadrant 1, because quadrant 1 is easy, right? Everything's positive in quadrant 1. We know a lot about quadrant 1, but don't forget, guys, if it's an open note quiz, that includes any notes. You can have your unit circle tomorrow. So if you've misplaced it, find it again, because you don't have to use your brain for it. You can use the actual unit circle tomorrow. So I'm going to take my my quadrant 1 angles and change their denominators to 12. And we did this somewhere else in the notes. If you don't want to write it again, that's your business. But it just makes it easier, right, when we have our denominator of 12 to find that sum. So I'm just multiplying my denominator by 2, so I'm multiplying my numerator by 2, multiply my denominator by 3, multiply my numerator by 3, and so on. And what 2 angles add up to 17 pi over 12? None of them, right? We don't have enough. There's not enough in our numerator to make a 17. So what do? Does that mean it's not solvable? What can we do? Go to another quadrant. That's exactly right, Steve. So I'm going to go into quadrant 2. And guys, there's a reason I'm doing this problem. Because tomorrow you're going to have a angle, I'm telling you ahead of time, where it's not just quadrant 1. You're going to have to go into another quadrant. Why don't you write the stuff here now? You don't have to do it again tomorrow, right? Open note. So in quadrant 2, all my numerators are 1 less, or pull out your unit circle if you need to. So this would be 3 pi over 4 and 2 pi over 3. Same denominator of 12 times 2 times 3 times 4. Okay? Everybody clear on what I did there? Do we have enough in a numerator to make a 17? Yeah. We can add these two together, right? 9 plus 8 is 17. 9 plus 8 is 17. So I'm going to use these two angles, and I'm going to use the sum formula for cosine. Okay? So cosine of 17 pi over 12 is equal to cosine of 3 pi over 4 plus 2 pi over 3. Okay? And that order, you could have written it in the other order. It's addition. It doesn't matter. Okay? And then using your brain or using your notes, alpha and beta, we're going to expand this. So we always start out by writing exactly that first trig function, cosine of 3 pi over 4. And then we remember that cosine is the shy one, doesn't like to be with other trig functions. So we'll do cosine of beta. So alpha, beta, plus or minus here, guys, minus. And then we do the same exact thing with the two sines. And then using your brain, using your unit circle, we're going to just substitute in these values. Cosine is negative in quadrant 2. We're going to the left. So this would be negative square root of 2 over 2. 2 pi over 3, that'd be negative 1/2 minus positive square root of 2 over 2 and positive square root of 3 over 2. And then simplify. Don't forget, with multiplication, you're going to multiply the numerators and the denominators. So this would be positive square root of 2 over 4, right? A negative times a negative is positive. And there's a minus. Square root of 2 times the square root of 3 is the square root of 6 over 4. And we talked a lot last week about the different ways you could write this as a one big fat fraction and whatever else. Now, no matter what two angles you use, as long as they add or subtract to get 17 pi over 12, this would be the answer. You would get the same answer. Like, for example, if you had flipped these, if you had put 2 pi over 3 first, totally fine. Your answer at this step would have looked like this. Okay? These mean the same thing. You go the same thing. Okay? The square root of 6 over 4 is the negative term, and the square root of 2 over 4 is the positive term. They're just flipped. Okay? But the answers mean the same thing. Okay? So you have two of those. Two. All right. We have two more examples to do and then lots and lots of time to work on the homework. The new material is these next two examples, but they're not really that new. What we're doing here is finding the solution to the equation. We're not verifying with a graphing utility. Just find the solution. Solve it. Solve that equation. No big deal, right? Just solve an equation. And we've done this before. If you want to write yourself a little note here, back in section 3.10, we did for like, I think 2 or 3 days, solving trig equations. I actually forgot that we had done that. And so let me just remind you, this is exactly what we did in 3.10, except for one extra step in the beginning, which of course I'll go over. But we had, it's going to scare you because it looks really crazy, but we had to solve equations. We had added 1 divided by 4, took the square root. Here we did factoring. We're going to factor today again. But if you want to go back to 3.10, or maybe you want to go to 3.10 tomorrow to see if there's a question like the one I give you on the quiz. Maybe there's one just like it in something in 3.10 that you can just copy the steps. I'm not trying to give you a hint. I don't know if that happened. I didn't look at that. But just that's another benefit of knowing where that is. Okay, so what we're going to do is solve this. But what's different from 3.10 to now is you're going to have to use one of your identities first to before you can start solving it. Because we don't want to solve an equation with sine and cosine added together. You can't really mix them with addition and subtraction. And so a lot of the time we're using double angle formulas. What I want you guys to recognize is that's your sine 2x. Friday, all of you were here except 2 of you. I don't know if you 2 had a chance to look at it, but for all of you, let's just remind ourselves, because last period they had totally forgotten about these two formulas. Remember, whenever you have sine 2, and that's a u, it can be an x, it can be a theta, it doesn't matter, it's just a variable, you can expand sine 2x to 2 sine x cosine x. That equals that. And then the double angle formula for cosine has 3 possibilities to use, okay? And we'll do a problem with a cosine double angle formula in a second. But when I see sine 2x, I can't imagine a time I wouldn't write it like this, okay? So if you see that in a problem, you're going to rewrite it like that, okay? So that's where that's coming from. And so when I do that, stay with me, I would rewrite that as 2 sine x cosine x plus cosine x. So you might be thinking, wait, she just said we're not going to solve it the way it is now because it's mixing sine and cosine together. But aren't we still mixing sine and cosine together? And the answer is yes, we are. But the problem just changed because what I want you guys to see here is that whenever you have a plus or a minus and you have identical stuff on the left and or the right, well, left and right, numbers, words, letters, it's a GCF problem. We can factor out the GCF from these two. Let's do that. I'm going to factor out cosine x. Okay, so understand, you don't have to show this step, but I'm just dividing both of these by cosine x. Whatever's left goes in the parentheses. So we would have 2 sine x plus cosine x over cosine x is 1. Okay? So you still might be thinking, well, we still haven't solved the problem. We've got cosine and sine mixed in the same problem. But now it's very different because they are factors. Factors mean they're multiplied together. We can set these each equal to 0 separately now. We couldn't do that when it was a plus or a minus here. You couldn't write this as sine 2x equals 0, cosine x equals 0. It's just you can't break up a plus or a minus like that. Multiplication, you can separate them. So what we have is cosine x equals 0. We're going to solve that. And 2 sine x plus 1 equals 0. We're going to solve that. And whatever we get as the answers is our final answer for this one, and this one altogether is our answer for the problem, okay? So this is just unit circle. X is your theta, is an angle. Where on the unit circle is cosine 0? That would be up here, and that would be down here. So x is pi over 2 and 3 pi over 2. We just solved that part of the equation. This one, we've got to isolate the sine x. Subtract 1, divide by 2. You don't have to show those steps. Subtract 1, divide by 2. So again, you're allowed to use your unit circle, but where sine is negative 1/2 is our denominators of 6, and sine is negative in quadrant, all students take calculus quadrant 3 and 4. So all 4 of these are my solution. 1, 2, 3, 4. 4 solutions to this. Sometimes you get duplicates, like you might get pi over 2 over here and pi over 2 over here. That's fine. No big deal. You can get more than one answer. Okay. All right. Last example. This one is factoring, the long factor, the chart factoring. This problem has like a lot going on in it. We've done them before, but it shouldn't be hard, okay? It's really important. I've been telling you guys this from day one that you have to know how to factor. You have to know how to factor, okay? There are 2 just like this in your homework, and there's 1 just like this on the quiz, okay? You have to know how to do long factoring with trig. So, you know, if you're halfway listening, pay attention with this one, okay? Let's do this one together. So just like the other one, it's solving. Solve the equation, okay? And what stands out immediately is cosine and sine mixed together with addition. I can't work with it the way it is right now. Hopefully we notice there's a double angle for cosine right there. Now, the double angle for sine, that's simple to work with. There's only one way to expand the double angle for sine. But for cosine, we have a choice of 1, 2, 3 different ones. How do we choose? Well, 2 of them, the first one and the last one, have sine in them. The one in the middle is cosine only. And remember, the goal is to try to get all the trig functions the same. So we're going to use this one here in the middle. I'm pretty sure that's the one you would use for all the problems no wait, that's not what I meant to say. That's a different problem. Okay, sorry. We want to use the sine one, right? We want to use this one because there's sine in the problem. We're going to change, this is a great way of getting rid of cosine and changing it to sine, is using this one. So what I was saying is I think the one in the homework has cosine right here. So that would tell me to use the one that's got cosine only in it, okay? So I'm going to replace cosine 2x with this one right here, 1 minus 2 sine squared. So cosine 2x is 1 minus 2 sine squared x. I just copied it right from there. Bring down the 3 sine x minus 2 equals 0. And so all I've done from the original problem to the red is expand that double angle. Now, guys, what I want you guys to recognize this is a quadratic equation. This is 2x squared plus 3x minus 2, and there's a 1 in front. So I'm going to start putting this in standard form. I want it to look like, I want it to look like this. Okay, so I'm going to put my negative 2 sine x, or negative 2 sine squared x first, then the plus 3 sine x. And then I have 1 minus 2 constants. That's the c value. I'm going to put them together. That makes minus 1. And when we factor a quadratic trinomial, a has to be positive. So if a is negative, hypothetically what you're doing is multiplying the entire equation by negative 1, which just changes everybody's signs. So you basically just change all the signs. Because if I want to change his sign, I'm allowed to, as long as I change all his friends. Okay, now what I hope you see is this, 2x squared minus 3x plus 1. I think it's easiest to go from trig to algebra for the factoring part and then sneak the trig part back in. So take out sine and just write it as an algebra problem. Now this is where we should feel comfortable. This is a chart problem. What two numbers multiply to get positive 2, right? 2 times 1, and add to get negative 3. Maybe those two numbers. And because of the 2, this is the longer method. We have to bring down the outside 2. So bring this guy down. Bring this guy down. And split the middle. We split the middle into these two. It doesn't matter which one goes first as long as you give them both an x. Okay. There's 4 terms. We do the parentheses. Parentheses around the front 2, parentheses around the back 2, and we do the So all they have in common is an x. Whatever's left over goes in the parentheses. Don't forget, when this guy is negative, you factor out a negative. And they only have a 1 in common. And if we did it right, which we did, our parentheses should be identical twins. And the factors would be one of the parentheses is one of your sets of parentheses, your twins, right? Doesn't matter which one. And then remember the hearts, x minus 1 equals 0. So if this was algebra, there's your factored form. I could set them equal to 0 and solve. I get x equals 1/2 and x equals 1 if I set them equal to 0. But remember, we were just tricking ourselves. This is not algebra. This is trig. So now is when we're going to slip the word sine back in front of each of your x's. Isn't this fun, guys? Love it. Love it. And now we're at the point where we just solve. So set these equal to 0, and then use your unit circle to finish the problem. So add 1, divide by 2. Sine is 1/2 at all of our denominators of 6. Quadrant 1 and quadrant 2 is where sine is positive. That's a quadrantal. That would be up at the top. And those are our 3 answers. Okay, there's 2 of these in your homework and 1 on the quiz. Now listen, in the notes, I did not show all these steps, okay? And I'll tell you when we get to number 2 and number 4 are just like this. Number 2 and number 4. I skipped like all of these steps, but I'm telling you it's this type. I jump back in like right here, okay? You'll see what I mean. All right, so homework is finally getting to practice set 3. And the review problems are just the bottom. I changed. Let me find it. So change number 5 and number 6. These, we haven't done these since day 1, so I gave you 2 of those. I think there's 2 on the quiz, 1 or 2 of those. And there's another identity problem where you have to prove, pick a side and stick with it. This is lots of factoring. Difference of 2 squares in GCF. There's a reason I put these on your homework today. Okay? And you have lots and lots of time to work on this. You guys have more than about a half hour, 30 minutes to do these problems. Okay? You should be writing these so I can take them down. Yeah. Yeah. 1 minus cosine squared theta. I'm going to start one with you because everybody had questions about number 1, the other 2 classes. So let me just go ahead and do this with you. All right, number 1. Oh, let me just write it right here. Okay, guys. Number 1. First thing you want to do is get everybody on one side together, okay? And we didn't have one like that in our notes. You want this to be a 0. And then here's a mistake, and I never thought about this being an issue. This is not, you cannot factor out a sine from both of these. Let me just show you something. If this problem was this type of problem, you could factor a sine out from both of them. But the sine, the 2 in the middle isn't like, remember we talked about this on Friday, you can't just move it out. It's doubling the angle. It's not 2 times the sine of x, it's double the angle. If you take the 2 to the front, it changes the problem, okay? So looking at this, I last period they were thinking, oh, we can just factor out a sine. You can't. Remember I told you, when you see a double angle, you're going to have to change it according to one of the formulas. And sine only has one of them. Okay, so I just changed that to that. And now you can factor a sine out. Remember, you know it because there's a plus or minus with identical stuff on both sides. Actually, I can factor out more than just sine. What else can I factor out? Well, yeah, x, and also what else? 2. There's a 2 on both sides, right? There's a 2, and there's a sine. So 2 sine x is your GCF. What's left over is cosine x minus 1. And now that we are factors multiplied, you can set them equal to 0 separately. So when I divide by 2 here, I just get 0, right? 0 divided by 2 is 0. Add 1 here. And sine is 0 to the right and to the left. And it is 1 also over to the right, right? So those are my answers. 0 and pi are the 2 answers. You can get duplicates, it's fine. Two and 4 are long factoring, just like we did in the annoying but not difficult. And remember, I skipped a bunch of steps in there.